afternoon all. My name is Jeff Houston. I'm with APNIC. I've got a lot of slides, so it's going to run a lot like a movie. We'll see how we go. You know, almost 20 years ago, there was this group set up in the IETF called the Routing and Addressing Directorate, because the theory was we were not just going to die once, we were going to die twice. Once was we were going to run out of addresses, and two, because the routing system was going to explode in our face. That mythology that the routing system is this unconstrained monster that is going rapid and unsustained growth, and it's all due to massive deaggregation, is a piece of thinking that persists even today. And when I read this kind of stuff, I keep on asking myself, is this real or is this bullshit? You know, to what extent is the routing table just growing and growing out of control? What's the real metrics about this? So in this presentation, I'd actually like to give you some underlying pieces of data that actually scope what is happening inside BGP and give you some projections as to how big a router you're going to need in 5 years, or if you're a vendor, how big a router you're going to have to manufacture to give it at least a 5-year field life. The caveat is I'm looking at one eBGP session. No iBGP, no richness of connectivity. This is one session. So your mileage might vary, but this is the base metric that you're going to have to start using in your multiplier. So here's the last 25 years of BGP. Oh my God, it's an up and to the right graph. Surprise, surprise. You can actually find a few things hidden inside there. The first time we thought we were going to die a heat death was back in '94. And so we whipped out classless inter-domain routing and felt very pleased with ourselves. And that minor blip was the success that broke out the champagne. It seems so inconsequential now. A bigger effort was in the year 2000 when we decided the internet really wasn't the great South Pacific boom of the 20th century, and we all got the blues for a couple of years and stopped expanding the internet. And then all of a sudden we discovered broadband and ADSL, and then we had a minor hiccup with the global financial crisis. You all lived through this shit the same thing as I have, but in 2011 we ran out of addresses. And in April of that year, 4 billion people on the planet over in Asia Pacific ran out of addresses. Did that stop the growth in the routing table? Not really. That's one of the sort of odder things there, that even running out of the basic supply of addresses didn't really stop the growth of the internet in terms of the routing system. That's the last couple of years. Again, it's an up and to the right graph, but it's not a curve anymore. It's not exponential. The best model I can actually put forward now is linear growth. Everyone's getting old and it's all just too hard to keep on doubling the pace. And that's the blow up this particular year. That's actually me, not you. On the 25th of June, I added one more upstream transit to where I was observing. And there are a number of folk in AS 7029, you know who you are guilty of this strange practice of announcing more specifics to some of its peers and aggregates to others. And as soon as I connected up an upstream, bang, 10,000 routes just hit me like a shock. Windstream, stop it. Be more sensible, restrain yourself. That's just vandalism. And the kind of growth curves you get as a result, that was a funny year in 2013. There was a period around the northern summer where everyone just went to sleep, and again sort of around that early spring period, and at the end of the year it's sort of, oh well, back to work. And it's sort of this strange mix of both growth and status. Is it just me? Well, it is just me, because when I look at route views, everyone else had a more even year without that discontinuity. So on the whole, relatively steady growth. Let's look at it a different way, how much addresses are advertised in the routing space, and that's where you see address exhaustion taking place. That growth in the amount of span in the routing space is slowing down because we're running out of addresses. I can show that more graphically when I look at the address pool itself, and in particular, that purple line. The amount of address space that has been allocated by the RIRs and not being advertised has been consistently the equivalent of 50/8 blocks and has been since the start of 2011. So whatever address trading and transfer and market proposals are out there, their effect on bringing unused addresses back into play on the internet has been, so far, minimal. In fact, I'll go further, invisible. So, you know, maybe something will change when Aaron runs out or when LACNIC run out, because both of those RIRs, as long as you're all well behaved and don't panic, as long as you do that and line up in a neat orderly line, Aaron will last until about the end of this year, and then it goes kaput, and LACNIC will go kaput at about the same time. After that, it's anybody's guess. The routed address space through 2013, AS721, some US government thing, can't decide whether it wants to announce 33/8 or not. Periods of indecision through the year, and AS80 decided that 3/8 was a bit too much and withdrew it. Yeah, right. AS numbers, new networks adding to the network. You're slowing down, you're getting old. It's no longer the same pace. It's not even quite linear. So how much did the internet grow last year in V4? I'd say around 10 to 12%. We've had years when it's been up as high as 30 or higher, but no, it's all slowing down. These growth rates are incredibly conservative. You say, it's all V6. If V4 growth is so slow, maybe it's all V6. World V6 Day, major change. Not. In fact, it's hard to actually see where the change is in V6. From that kind of perspective of the last 2 years, it's possibly a bit more than linear, possibly. Yeah, okay. What about the address span? Nothing spectacular. Routed AS count? Wow, tapering off, not growing. This is getting a bit weird. What's the growth levels like? They're much bigger than V4. 40, 50% in some cases, but overall I'd say the V6 network grew by between about 20 to 40%. A couple of years ago it was 90%. So whatever action we're doing with V6 is not the same. And if I just look at AS numbers alone, if we keep on adding AS numbers to the V6 internet and at the V4 internet at their current rates, we'll get to parity in 16 years' time. God knows how big the CGNs will be by that stage, but they'll be bigger than this room, I can assure you. So, you know, the next part of this is when you look at that, you go, well, how big a router do I need based on these projections? If the routing table continues to grow despite address exhaustion, and so far it has, if we keep on routing ever finer and finer prefixes and keep on adding into the routing pool, what can these numbers tell us? Well, with the great power of mathematics, we can get some models out there, and there's some application of some models to the curve. And we can have a look at the first order differential. Remember that? It's called mathematics again. And we can do some rough modelling across that. And we can look at how those project. And what we end up with is this table. Conservatively, we're currently sitting at around 500,000 entries. In about 5 years' time, 750,000 entries seems a reasonable projection. The outer limit of that is an exponential model. So if the extreme level of uncertainty, we're probably going to get just a little under 1 million entries in the routing table. But at this particular perspective, there's no reason to suggest an exponential model of growth. That column there of linear growth seems far more likely as far as I can see. So what's in your fib 5 years' time? 750,000 entries in V4. V6, yeah, tougher. It's kind of hard because those first few years it was sort of low, and while the entire model looks exponential, recent experience hasn't been like that. That's that first order differential, and again there's a lot of noise inside that. But I can do these projections and I can come up with much the same figure. An exponential model, 5 years' time, 127,000 entries, linear, 35. Hard to say what to make out of that. But realistically, the question that you and I both have is routing going to get more expensive or not? And the real determinant of what makes this stuff more expensive or not is whether silicon can grow at the same pace as the routing table. In other words, does Moore's law, this whole idea of being able to double approximately every 18 months, is of much the same order of magnitude of routing or not? So there's Wikipedia, Moore's law. If you go up to the right, you get more expensive per unit. If you go down to the green, it gets cheaper. There's Moore's law applied to the BGP routing table in V4. Does anyone think we've got a problem yet? Because I can't see it. You know, Moore's law is rocketing upwards, whereas the routing table's kind of meh. How about with V6? Well, if you take the exponential load in V6 and map it to Moore's law, you get something closer. You might thinking, well, there's possibly an issue there, but realistically, those numbers are low. Growing from 16,000 entries to 160,000 entries is, in the absolute order of things, pretty much nothing. The major determinant of how big a router you're going to need over the next 5 years is still going to be V4, not V6. So is BGP got an issue? Are we still okay? Well, someone would say it's not the size of the thing you're dealing with, it's what you do with it, right? So let's look at what we do with it. Let's look at the update load. Singly BGP session, one default feed. Holy shit, that's not an up and to the right curve. That's 7 years of routing updates. The network's grown from 100,000 to 500,000 entries. The number of updates I see has grown from 90,000 a day to 100,000 a day. Why are you all so well behaved? What's going on? The number of withdrawals is consistently 1/10 of the number of updates, and nothing has changed for 7 years. And the number of unstable prefixes that get updated has grown from 20,000 to 25,000 over that same period. It's your fault. This is your fault. If you look really closely at the vertical lines that mark Christmas and New Year, what can you say about the number of unstable prefixes? It falls. So let me relate this. When you're not at work, the network is really stable. Well done, guys. This is you, no one else. Convergence performance. Oh dear, the network's getting harder and harder. BGP's flogging itself trying to reach convergence bullshit. On average, things converge in precisely 45 seconds. And even if I look at more complex events that take 2 or more updates to converge, those complex events converge within 70 seconds, 2.25 MRI intervals. Nothing in BGP looks like it's melting. Why? Because as we grow the network, all of you want to crowd into the same room. It's as if we doubled the number of people but kept the diameter of this room, and then doubled it again, and then doubled it again, and still kept the same diameter. No matter where you look in route views, everyone sees much the same average AS path length. And for a distance vector protocol like BGP, that is the critical metric. And that's why the network's been so stable. You like each other way too much to live at the edge. You crowd into that centre. So this kind of sort of boring. What about V6? Someone decided to damp me heavily in 2010, but that's kind of weird because before 2010 the number of updates grew, and after 2010 it stopped growing. It stopped. Again, it's behaving like V4 even though it's tiny. And guess what? Again, the number of updated prefixes is really, really low. Tell you what though, when you go home over Christmas and New Year, you play in the V6 network, because on those periods the V6 instabilities are about the same as all the rest of the time. So that's what you do across New Year. I've found out now, your secret's out. Convergence performance, well, when I had that funny upstream, my convergence was all over the place. But on the whole, it takes slightly longer, about 80 to 90 seconds on average for a convergence event in V6. I suspect there's more infrastructure tunnels, and I suspect those tunnels take longer to converge, and that alters my average performance. I suspect. A little bit of work needs to go into that. The other thing is, when I look at average AS path length, that solid blue line is me. I'm the outlier. I'm the guy right over at the edge with a 1 AS path longer, and I suspect that's actually making my numbers worse than the numbers you might see. So, you know, V4, V6, there's nothing untoward here in these numbers. But maybe we can look a little bit elsewhere, because realistically, most of you treat BGP like a garbage dump. And most of you put all kinds of shit out there and just don't care. Look at this from Relcom. There's a /15. Oh, it's not good enough. On exactly the same path length, let me give you a 24 and a 24 and a 24 and a 24 and a 24. Well, that's Relcom, that's not you. Are any of these you? Might be, might not. That's the list of the worst offenders in terms of announcing specifics needlessly. So how much of the network is more specifics? Shitloads. That's that red line. Let's look at it as a percentage. Somehow, with astonishing accuracy, as if it was a plan, half of all the routing table entries are more specifics. How do you do it? I couldn't do it, not by myself. I couldn't be so unerringly accurate for years, but somehow collectively you have this uncanny ability to just get it right. You're weird. Does everyone see this? I look at route views, everybody sees this. It all stabilizes that half of the routes we announce are more specifics. Oddly enough, more and more of the network's address space is being consumed this way. 10 years ago, 20 years ago, it was less than 5%. Now, most folks see 1/4 of all address space is qualified by a more specific advertisement. Little by little, even though it's still only 50%, 1/4 of the announced address space is covered by more specifics. Does everyone do it? Wow, no. 332 Origin ASs announced 50% of the total set of more specifics. So a very small number of you announce most of these more specifics, and most of you announce none. The top 20 ASs announced 40,000 more specifics. So a very small bunch of you, you lot, just those few over there, are behaving violently aberrantly, and everyone else is copying all of the load from that. That's kind of what we're seeing right now inside BGP. That's that same list. If you're on that list, do something about it. What about V6? Have we learnt anything better? No. The more specifics are now climbing up, and they're currently around 30% and growing. We'll get to 50% within a year or two, never you mind. Does everyone see this? Well, yes, except one particular peer of route views that filters like crazy. Everyone else sees it. How much address space? Well, it's small now, it's 1.6%, but it's growing and growing and growing. How do you manage to have exactly half of the number of routes as more specifics? So I take the top 10 more specifics and I track them for the last 3 years. And I'm amazed. Some folk just persistently, every day, put in a few more specifics into the routing table. Those are the lines up and to the right. Some folk announce fewer. Those are the lines that go down and to the right. And some have these dramatic step functions that all of a sudden spin out to the world a huge amount of specifics. I find it amazing that out of such a noisy history, you get this really stable 50% metric that some of you learn, some of you are determinedly ignorant, and some of you seem to be getting dumber by the day. And the end result is half of you are dumb and half of you aren't. I don't understand. So, you know, I look at this and go, why are you doing it? And as far as I can see, there are a number of reasons. One is you're hole punching. In other words, you're taking an aggregate and I'm doing a different origin AS. I'm announcing a more specific from a different origination point. And some of you seem to be traffic engineering. You're pushing your incoming traffic across multiple paths, so you're advertising down different things. And some of you are doing what you would call protection. Let's see exactly how this looks. I take all the specifics and I categorize them in 3 ways. Specifics that have the same, exactly the same AS path as the aggregate. That's the red line. Specifics that have a different path but the same origin. That's the green line. And specifics that have a different origin completely. Traffic engineering, hole punching, and of course senseless routing vandalism. And of course senseless routing vandalism tends to win. I could do that as percentage, and around 45% of all the more specifics are senseless routing vandalism. What can I say about those in terms of updates? Are more specifics noisier than aggregates? So I punched through 3 years of updates, 100,000 a day for 3 years, you do the maths, it's a lot of them, and I try and categorize all those updates into what I see. And it gives me that graph, which is lots of colors. But let me break it out a bit in percentage terms. The green are the updates of more specifics. The blue are the updates of the aggregates. Shit. Half of the network is more specifics, but 80% of the updates are more specifics. Those more specifics are contributing 4 times the update load of the aggregate. So if you're wondering why things are churning, those small group of people over there we talked about are your problem. Kill them and your BGP will go quiet. You could route the whole network on the same processor used to take the lift up to the 50th floor. While they're still there, buy more routing hardware, because that's what's going on. Relatively speaking, the more specifics are your problem. And I can do a bit more work and contrast those updates against the type of routing. And oddly enough, the senseless routing vandalism is proportionately not all that bad. And again, oddly enough, even green, the traffic engineering, is not all that bad, but the blue is a lot higher. So what's actually I'm thinking is that hole punching, where I've got a different origin AS, tends to contribute way, way more proportionately in the update load than any other kind of more specific. So more specifics are noisy, and different origin AS is proportionately even noisier. So that's sort of the data that we see. Is it a problem? Should we sit there and gang up on those poor people over there and tell them to stop it, or we'll kick them out of the internet? Is this really causing us that much problem? As technologists, we tend to be obsessive compulsive. Admit it, we all are. And when you see a problem, half of you, all of us, most of us, whatever, go, gotta fix. Could we do better? Absolutely. We could indeed do a lot better, because we could be a lot tougher about filtering out more specifics that have exactly the same AS path, because it'll reduce the table size and reduce that level of dynamic update churn. You'll find a routing table that has a lot steadier set of properties than what we're currently seeing. So could you do better? Of course you could. But should you? So many hours in the week, so much time, so much to do. What should you do? Well, if I was managing a team of folk and sort of this was one of my problems, I'd be hard-pressed to actually say that it's my burning problem. I don't think a table growth that rises from 500,000 to 750,000 over the next 5 years is going to cause me massive heartache. Maybe it might cause you massive heartache, I don't know. But as far as I can see, these numbers are relatively modest. They're not burning through silicon like crazy. I don't need the latest generation of hardware for next week. I can, I think, comfortably buy a product today and leave it deployed in the field for the next 5 years within those parameters of these numbers. So is it a problem? Gee, I tend to say no. But then again, maybe your mileage will vary. We could do a lot better, and some of you might want to, and that's good. But do we actually need to? I'm not sure I would. So that's what I saw in 2003. Hopefully I haven't gone so fast that I've left you all dazed and confused, but we do have some time for questions. Thank you.
Lee Howard. Earlier in the presentation, you talked about the growth trends in IPv4, IPv6, and routing table entries, and I wanted to know if you had looked at various different curves for when the number of entries in the IPv6 table converges or crosses the number of ASNs, i.e., when do we have roughly one v6 prefix per ASN?
I hadn't looked at that one. What I was thinking, of course, is that trying to get the number of prefixes to match up is kind of hopeless, because in some ways the v4 prefix table has this cruft of neglect, history, and swampland that, in theory, we're not reproducing in v6.
Right.
We are actually, but let's not talk about that. So then I thought, well, maybe the real metric is AS numbers. And I was looking at the growth in AS numbers on each side, thinking, well, every AS in v4, sooner or later, has got to be an AS in v6, or you dog meat. You either get with it or get out. So I was doing that number and projecting forward. And a couple of years ago, the crossover point was 2018, and I was thinking to myself, geez, I feel good today. and I did these numbers for this presentation and came up with the depressing fact that it's now on these numbers 16 years out, 2030, and that's not going to work. That's just way too slow. So somehow that momentum of whatever we had with 6, We've left it to a few of the biggies. We've left it to a number of the big broadband rollouts here in North America. We've left it to a number of retail rollouts in Europe and in Japan. And everyone else is comfortably sitting there looking at them going, not my problem this year. And maybe that's not a good thing.
Yeah.
I guess I was going back to your original question in the beginning, Jeff, and I was curious, what are the router resources that are being consumed that would cause you to have to get the next router up?
Okay. On most routing instruments, you need high-speed memory near the line cards, TCAM memory, and you send it a destination address, and it has to sort out what interface to do with that. So typically, the amount of entries in your fib becomes the TCAM space you need to reserve in your machinery. And that memory is much more expensive than any other kind of memory. So typically we talked to ourselves and had huge anxiety when we needed more than 64K of TCAM, when we needed 128K of TCAM, and now 256K. And of course these days you need 512K of TCAM to hold a fib in terms of 32-bit entries, in theory. And the issue comes, how much are you going to need? And as far as I can see, and the caveat is, I've never made a router ever in my life, but some of you have, so you can correct me. The theory is that that was one of the major determinants on router cost. But you know, if you're a router vendor, please explain. Because you're at the microphone.
Dave Swanson, Windstream.
Ah,
Yeah, I'm
well, thank you.
BGP public enemy #1. So, for what it's worth, I actually agree with you. I hate when I have to make those configuration changes and announce the particular things that you were talking about. And you actually hit the nail on the head with your suggested reasons why we have to do it. I'm completely open to suggestions to convince, I guess, the community at large why we shouldn't do it, because you actually kind of summed it up yourself that we're not burning through silicon. What's the big deal?
So let me explain a little bit further for those who haven't been in on this for some time. We hooked in Hurricane Electric mid-year. And for all of my other transits and streams, I see a /12 from Windstream, because that's what they advertise to some of their relationships. But when I hooked up Hurricane Electric, there was no /12. There were 3,561 more specifics. And all of a sudden I'm getting a /12 from one set of folk, and of course all these more specifics from the next. I see a jump. Most other folk in route views don't see that, and didn't see that. So it's because of my configuration that I get this. Now, my first question was to Hurricane Electric going, why don't you just filter it out? And they go, we didn't see the /12. All we saw was the more specifics. So it is an interesting question, and I had the same pondering as you, going, geez, what's right here? My suspicion is there's a twofold benefit in these more specifics. One, by advertising all these, it makes it harder for someone else to steal that prefix. If you're advertising a /24, what does the attacker advertise? A /25, everyone filters. So in that respect, you kind of go, well, that makes sense. But underneath this as well, I understand, by doing that, you have a lot of control of your incoming traffic that the aggregate doesn't give you. So like you, and I used to work for AS1221, which was exactly the same role as you were today. We were the biggest deaggregator on the planet. And we sat there and said business reasons. And I can sympathize with the view. I'm not sure I have a clean answer for you, but you can see the results of your work. That's all I can say.
The results were actually quite nice. It was very interesting to see that. So, but yeah, I mean, the question stands. I mean, anybody that can give me the good reasons on, you know, why we shouldn't continue that practice, go for it.
I'm interested too, if anyone has. Bill.
Bill Manning. I would suggest that there might actually be an unstated, or you have not yet stated, another advantage or for this kind of churn in the routing system, and that's education. Some of us have been doing routing for a very, very, very long time, and we have been burned a lot, and we have the scars to prove why it's a bad idea to do some things and not others. But the young pups that are just coming up are kind of gun shy when it comes to making mistakes because they don't want to get yelled at by Jeff from the podium, quite frankly. And I think that there is a place and a time to allow people to learn and to understand why some things are suboptimal for others when they optimize locally, and why optimizing globally and can screw you up locally. We need to have a better mechanism for teaching people how to deal with an evolving routing system than we currently have. And right now all we've got is sticks, and it makes people afraid. A stable routing system is a stable routing system, but we don't live in a stable world. We need a dynamic system that is growable without having people get angry with us for what looks like dumb things from some perspectives. So education of the next generation of routing engineers, we need to take that into consideration. And
Thanks, Bill. I'll just before that next question, I'll just add one more comment here. As a group, we have a really short attention span, and we're highly distracted by what is currently in fashion. We spend a lot of time developing a route registry, developing mechanisms to describe how to limit the propagation of routes and logically express relationships and dump them all in a registry and allow others to compute routing filter lists so that would indeed say, I wish to advertise more specifics around this area, but let everyone else see my aggregate. And we also thought it was a good way to try and control unauthorized routes, that it was also a security mechanism. Route registries gained in popularity, everyone thought, well, this would be good. But a lot of us didn't use it. And then along came things like RPKI, bright, shiny new security. Let's stop the route registry work, let's go to RPKI. RPKI offers you security but no policy, that everything you do in RPKI is still global. I can't control the propagation of the information I send out. So it might give you security, but it doesn't give you the other things we were trying to achieve in the old route registry model. The BGP problem is, as Bill suggests, a big problem. Trying to achieve policy, trying to achieve optimal business models and reachability all at the same time is, as Dave points out, really difficult. And sometimes you're just forced into this more specific advertisement because that's the only way you can get your business needs filled. But what you do is now everybody. We all see it. And that's part of the problem here. So we need better answers. And with that, hopefully you've got one.
Yeah, Dan McGinn, Pier 1.
Closer to the mic.
Dan McGinn, Pier 1. So we have problems where people give us aggregate routes where it affects our traffic engineering. We're learning a large aggregate route, and then we're learning many small routes, and all else considered equal, we naturally pass the traffic to the more specific route. When we have network connectivity issues due to latency spikes, jitter, packet loss, and we're going through the preferred route, is extremely ugly, messy, and difficult to traffic engineer over to the aggregate route. And for this, if no other reason, it would be nice if people would stop. Personal opinion.
It's tough, and the only thing we've got at the moment is a language of communities to try and inform how we want propagation to happen. Some folk are really good at communities, other folk treat them as, well, an idle thing to do when you've got nothing else to do. We've got to take this more seriously, or you will need bigger routers in the future. Thank you. Oh, one more.
William Shard from Line Networks. Just two quick questions. And I'll also comment, I was one of these people who has spent a lot of time yelling at some young pups for making mistakes, but I never did so without giving them a full explanation of exactly why what they did was wrong. And I think that there, from some of the things I've heard, that there are a fair number of people who don't bother with the explanations and just deal with the correction. And that's a problem that we have to fix as teachers. With regards to V6, do you know, have you looked to see what percentage of the prefixes, what percentage of the ASNs in the table are advertising both V4 and V6 prefixes, and are there ASNs that are advertising only V6?
I could tell you that, but my memory is not that good. I do track the number. From memory, we have in V4 network transit ASs that are in the interior of an AS path and ASs at the edge. Around 60% of the transit ASs in V4 announce V6, and almost none of the edge. So the folk in the middle who do business for others in 4 have a relatively good strike rate in being seen in 6. The folk at the edge at the V4 network, a wasteland.
That's one thing that always fascinated me looking at the BGP report was the number of transits versus the number of origin-only ASs, and being able to just do a logical deduction and say, okay, well, these aren't actually offering services to the edge versus these are serving the end users, and reduce that to, the total number of service providers on the globe is X.
Exactly. Thank you, and thank you.
Thank you very much, Jeff.